First, we'll focus on the older historical goal for dealing with the multiple comparison problem. It uses the term family-wise. Suppose you have a family of questions you're asking, a set of questions. And for each of those, you could create an interval or you could run a hypothesis test. First, we'll talk about the family-wise confidence level. The confidence level for one particular confidence interval is, say, 95, which means there's a 95% probability that that interval covers its true value. A family-wise confidence level is the probability that every single one of the confidence intervals that you have in the family covers its true value successfully. So what we can set as our goal is to have a 95% probability that all of the intervals cover their true values. The more intervals we have, the lower the chance they'll all cover their true values. So we're going to have to work pretty hard to make sure that they all will cover their true values with a probability 0.95. Similarly, we can discuss the family-wise errors for a family of hypothesis tests. The family-wise error rate is the probability that at least one of a set of null hypotheses is falsely rejected. So we might do one hypothesis test where the cutoff for the p-value is 0.05, which means there's a 5% chance that we will falsely reject the null. And if we have a whole family of tests, the family-wise error rate is the probability that at least one of those null hypotheses is falsely rejected. The more tests, the higher the chance that there'll be at least one type 1 error, so we're going to have to work pretty hard to put a cap on the family-wise error rate and reduce the probability that there'll be at least one mistake. Looking ahead, this family-wise confidence level and family-wise error rate are in contrast to the more modern goal we could have for multiple comparisons, which says, let's make sure we limit the proportion of discoveries that are incorrect. So if I'm going to do 100 tests, I want to make sure that only a certain proportion of my findings are spurious. Only a certain proportion of the null hypotheses that I reject were falsely rejected. So the family-wise confidence level and the family-wise error rate have to do with the probability that you make no mistakes, whereas the more modern goal has to do with putting a cap on how many mistakes you make, knowing that you are going to make some. Again, the family-wise confidence level and the family-wise error rate have to do with the probability of being perfectly successful, no mistakes for any of the tests or intervals that you do. Whereas a more modern goal is to put a cap on the number of errors you make, knowing that you are going to make some. Here's an outline of the methods that we'll discuss for addressing the multiple comparison problem. We'll talk about Bonferroni, Fisher, Tukey, Chaffee. Those four all have the first goal of dealing with the family-wise rates. And then we'll talk about Benjamini Hochberg and a more modern one, Carvajal Rodriguez, which deal with the second goal.